C++ arrays. Now here we are having one integer array having the name n with 10 consecutive locations, and here the subscript or the location number will be ranging from 0 to 9. So we are executing one for loop, and the for loop is extending from 0 to 9. So int I is equal to 0, I less than 10, so I can get up to 9 only, and I plus plus I will be incremented by 1 always. Ni, that is at the ith location of the n array, I plus 100. So the value of I will be at first will be 0. So 0 plus 100, 100 will be assigned. 1 plus 100, then 101 will be assigned. 2 plus 100, then 102 will be assigned. In this way the values will be assigned accordingly. Set element at location I with I plus 100. So now here we are printing headings, that is the element and value. So if we compile our program, and if I want to show you that how the outputs are coming. So now here you see the element is the respective text. This is the respective text we are having element, and set with 13. We are having this set with 13 characters, and then value, and then endl. So here we are having 13 characters. Out of them value is having 5 characters. So here in between we are having 8 characters gap, so that we are having this output in a very columnar way. So for int j is equal to 0, j less than 10, j plus plus. So again the j is ranging from 0 to 9. So cout set with 7, and then we are printing this value j. So here you see we are having this 7 is a width, and then 0 to 9 they are the single digit numbers. So as a result of that we are having 6 blank spaces beforehand, and then numbers are getting printed. And then set 13, again we are denoting, we are having this set with 13 characters, and out of them 3 of them are getting occupied by the 3 digits. So 10 blank spaces beforehand, so they are coming. So set with 13, and nj, we are printing this current value of this n array at the jth location, and endl will bring the next line, printing in the next line. So in this way this particular array is getting defined, array has got initialized, then array content is getting printed. So in this way we have explained this program line by line. I think now your conception is getting clear at this particular stage. C++ bitwise operators. Let us explain this program and also to show you that how the bitwise operation can be done in C++. So here this value of a is equal to 60, in binary it has been expressed in this way. Value of b is equal to 13, so in binary it has been expressed in this way. And c is equal to 0. Okay, now a and b. So that means I shall be doing the bitwise ANDing. We know that 1 and 1 is 1, and 1 and 0, or 0 and 1, or 0 and 0 will produce output 0. So if you do this bitwise ANDing, I'm getting this 1 1 will survive, and all of the rest bits are getting ANDed with either one of the zeros will be there. So as a result of that, the output will be like this, which is nothing but 12. So if you print the value of c here, so I'll be getting 12 here. So in case of odding, the output will be like this one. The decimal equivalent is 61. So accordingly it will get printed. So 61 is supposed to get printed here. Okay. Now here we are having the respective values, that is a XOR b. So a XOR b means we know that 0 and 1 and 1 and 0, their XOR will be 1. 0s are 0 and 1s are 1, the XOR will be 0 in that case. So similarly, if we do this XORing, the XOR will be denoted by this particular upper caret symbol. So there is a representation of XOR. Okay. Now, so if you do the XORing between this a and b, so then the output will be obtained as like this one. So you just go on doing the XORing, we will be getting this output like this, and that will be 49. So 49 is supposed to get printed here. So here we are doing this complement. Complement means ones complement. So 0011, 1100 will be converted to 1100 and 0011, and which is nothing but minus 61, because here this one will indicate the number is negative, and the respective value will be obtained by taking the 2's complement of that. So it is minus 61, so value will be minus 61. So line 4, the value of c is this. So let me execute the code also side by side. So here we are getting this, that is c is equal to minus 61. Okay, now next one is a. There is a double arrow. This particular double less than symbol will indicate that we are moving this a. All the bits in a will be shifted towards the left hand side. So left shift will take place for 2 bits position. So ultimately we are getting this value, and this value is nothing but 240. And here we are doing this write sheet for two places. So here is the respective value whatever we are going to obtain. So if we do the left sheet for two places, then in that case two bit positions, then in that case these two zeros will disappear. And if we do the right shift for two places, two bit places, then these two zeros will be disappearing and the free space will be filled up with zeros. So as we did here, so it is nothing but 15. So similarly we are getting this output like this. Now let me execute the same code. Now let us execute the same code in our GNU. So G++, program name is prog16.cpp, -o a.exe will be the output file name. So if I execute the code now, after compilation, we're getting the same output which we obtained in case of dep C++ output. So in this way, we have explained the execution of this program, and this program is dealing with different types of bitwise operators. C++ relational operators. We are going to execute our code and we shall explain the output line by line. So here we have done the compilation and run. So here we are using dep C++ for the execution of our code. So this is the respective output. So A is equal to 21, B is equal to 10, and C is defined but uninitialized. So A is equal to B is false. So that's why the control will be coming to the else part, and line 1 A is not equal to B. So line 1 A is not equal to B has got printed. Now A less than B, A is equal to 21 and B is equal to 10. So A less than B is false. So the control will be coming to this else part. So line 2 A is not less than B, A is not less than B, so A is not less than B. So the corresponding output has been explained logically. So now if you go for the next part, that means A greater than B, and here it is true because 21 is greater than 10. So line 3 A is greater than B is going to be printed. So line 3 A is greater than B has got printed. So now here we are having A is equal to 5 and B is equal to 20. So now if I go on printing, A is equal to 5 and B is equal to 20. So if A less than equal to B, so A less than equal to B is true. So line 4 A is less than or equal to B. So line 4 A is less than or equal to B. And B is greater than equal to A. Line 5 B is greater than or equal to A. So B is greater than or equal to A. In this way, we are getting this output logically explained. C++ logical operators. Now let us explain this program with the execution. Here value of A is non-zero, that is 5, and B is also non-zero, that is 20, and C is uninitialized. So A and B, here we are doing this particular logical operation. So here is a logical operator AND. So A and B, here we are getting the line 1, the condition is true, because here A is non-zero and B is also non-zero. So now non-zero means both are true, so true and true will be true. So the condition is getting satisfied and the output is obtained. So let me execute the code at first so that we can have the better understanding. So let us execute the code in GNU++. So we are having this compiler G++, and then our program name is this one -o. The output file will be say a.exe. So after compilation, if I execute, I'm getting line 1 condition is true. So really I'm getting this line 1 condition is true. A or B, here both A and B are non-zero, so both are true. So true or true will be output will be true. So line 2 condition is true is getting executed. So now A is equal to 0 and B is equal to 10. So A and B will be returning the value 0 here or false here, because 0 means false and non-zero means true. So false and true output will be false. So condition will be going, the control will be going to the else part. So line 4 condition is not true. So line 4 condition is not true. So the output is coming accordingly. And if you take the negation over it, so if we do the complement of that, then we are getting line 5 condition is true. So line 5 condition is true is coming accordingly. So if we do the compilation and if we do the execution in dep C++, we are supposed to get the same output. Really, we are going to get the same output as we got in case of GNU C++ program compilation output. So in this way, the program has been explained. C++, the hash operators. In this program, we are going to define the usage of the operator hash. We know that operator hash causes a replacement text token to be converted to a string surrounded by quotes automatically. So here you see, here we have written this mkstr hello C++. So please note that here this hello C++, this particular string is not enclosed within double quotes. So we have defined one macro here. So hash define mkstr x hash x. So that means this particular x is nothing but hello C++, and it will be enclosed within double quotes, and accordingly the output will be obtained. So now let me execute my code. So I have clicked on compile and run option, and now if I execute my code, I'm getting this hello C++. So thus we have explained the usage of operator hash, which is causing a replacement text token to be converted to a string surrounded by quotes. C++ hash operators. Here we have defined concat a comma b, a hash b. So in this program we are supposed to discuss the usage of the operator double hash, and when this concat appears in the program, its arguments are concatenated and used to replace the respective macro. So here we have used this concat x comma y. So now this x and y will be coming down here, so they will get concatenated, so they will become the variable xy, and here we have initialized this variable xy with the value 100. In the similar way, str and 1, so when they will be coming to str and 1 to a and b, then obviously this str and 1 will get concatenated. So as it is hash defined, so preprocessor will come into the play, which will replace this particular part by xy, and which will replace this particular part as str1. So the respective variable xy content will get printed, and respective variable str1, its content will get printed. So preprocessor will come into the play, which will do this macro substitution, that means replacement of this particular macro called by the respective macro body. So now let me execute my code, and I'm expecting 100 and hello world going to get printed as the output of this program, and according to our planning, yes, we have got this 100 and hello world has got printed here. And this is a very good example of uses of hash operators and macro substitution. C++, the raise function. In this program we are going to discuss this function raise. You see, like the previous program, here we have defined one signal handler function, and here is a signal function which requires two arguments. The first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. When the signal will be generated, how to handle the function, how to handle the situation, that will be written in the respective function code. So in this way we have written this signal handler here. We could have given a separate different name according to our wish to this respective function as well. So now here you see, here this value of I is equal to 0 initially, and this while is not falling in an infinite loop. It is just going for I is equal to I plus 1, that is plus I, here we have written. But when this value of I is equal to 3, that means when this value of I is equal to 3, then we are raising sig int. So in this way, when the value of I will be 3, then the signal int will be raised and the corresponding program will halt here. Okay, and each and every time after printing going to sleep once, it will wait for 1 second delay. To have this particular function running, we had to include this respective header file, that is unistd.h. Okay, now let me execute the code at first. So you see, if I execute the code in def C++, the output is coming like this one. So interrupt signal 2 received. So here this value of this signum is 2 here. The value of the signum is 2 here. So accordingly it is getting printed. C++ pointers to structures. Let us explain this program. So here we have defined one structure variable. The name of the variable is books, and which is having 4 fields. First 3 fields will be of string type, so that's why we have defined character arrays for them, and the last field is of the type integer, which is containing the book ID. Here we have defined 2 structure variables. One is the book1 and another one is the book2. So now to initialize first 3 fields, we have used strcpy function, so that we can copy these values to the respective fields as well. And this is the book ID has got initialized. Similarly, for book2, we have initialized all the 4 fields with their respective values. In the print book function, this is a print book function which is taking one address of the structure variable. So that means it is taking the address of the structure variable book1. So as a result of that, the respective prototype for print book will be struct books pointer, and it is returning nothing as output argument, so its output type will be of void. So it is returning nothing, so the output type will be void, and it is taking structure variable address as input argument, so that's why the input argument data type will be struct books pointer. We know that in case of prototype declaration, this variable name is optional, so instead of writing this struct books pointer book, we could have written only struct books pointer. Okay, now see, that is the function body. Here we have defined the function body. So struct books pointer book is there. Now to access the respective fields, I cannot use the dot, that is a membership operator, because here this book is not a structure variable, but it is a structure pointer variable. To access its respective fields value, I must be using implies, that is minus greater than, implies operator. So book dot title is not applicable here, so book implies title, book implies author. In this way we could have retrieved all the 4 fields value. So let me execute the code at first, so that we can get the idea that how the outputs are coming accordingly. So we have initialized book 1 and book 2, and also we have printed book 1 and book 2 respective values, and you can find that the values are coming quite perfectly. So here instead of using book dot title, we should be using here book implies title, as book is not a structure variable, but it is a structure pointer variable. C++, the namespaces with directives. In this program, we have defined 2 namespaces. The namespaces, the first one is the first space, and the second one is the second space. In the first space, we have defined one function with this body, and in the second space we have defined the same function with the same prototype, but the body is containing the statement like this one. So now int main, from the main function I'm calling this func, func. This particular function has been called, but if we use this namespace first space before this particular main, the function body, then in that case let us see that what will be the output. As we have written using namespace first space, so this first space, the respective function, that is the func, this function will be called this one, and as a result of that, inside first space, that message will get printed on the screen. So if we change this one, if I make this one as second, if you go for the second space in that case, then we are expecting that this particular function func is supposed to get executed, and inside second space this message is getting printed on the screen, on the console. So in this way we have got the idea that how this namespace is playing a very vital role in the decisive factor that which function is going to get executed when both the namespaces with the different names but having the same function prototype but with the different body as well. I think now the conception is getting clear to us. C++, the signal function. In this program, at first we shall register the signal sigint and the signal handler function through the signal function. So here is a signal function for us. We have called this signal function, and the first argument as an integer which represents the signal number, and the second argument as a pointer to the signal handling function. That means when that corresponding signal will be generated, then what is the respective activity we are going to do. So that has to be maintained or mentioned in the signal handler function. So here you see, here we are having this main function, and the main function has gone for an infinite loop, and it will go on printing going to sleep, and that is one sleep function we have called, which will make the program halt for 1 second. And in this case, to have this particular function defined in this respective header file, so that's why we have included this one. Okay, now let me execute my code for the better understanding. So now when I shall execute, when I shall click on compile and run option of this dev C++, then we are finding this each 1 second we are going to get going to sleep, this message is getting displayed. Until I press Control C from my keyboard. So if I press Control C, then I'm coming out and the last line printed was this one. But as the corresponding output screen has gone off, so that's why we could not see the output properly. C++ class template. In this program, we have defined this T as a generic type name. We have defined one class named as stack, and which is having the private member, that is vector elements, and what kind of data we are keeping in this particular elements will be of generic type. So now under the public section, we have defined function number 1, that is push, function number 2, that is pop, and function number 3, that is empty. So in this way, we have defined this respective class, and in the outside of this class, we have defined all the member functions with the respective body. We know that this is : which is denoting the scope resolution operator. And here we are having this void stack T. As I told you that T is the generic type here. And under this particular stack class, we are having this push method, the member function, and this is the respective body here. So ELEMS is nothing but a vector object, and pushback is the respective member function which is already defined under this vector object. So similarly, we have defined this pop function. Also, we have defined this stop function, and which will check whether this vector object ELEMS elements is empty or not. If it is empty, then it will throw one exception, that is out of range exception. So now in the main function, we have defined one object under this particular class stack, and here we are doing this data type binding, that is int type, and stack string stack. So here we are defining two objects. We are defining two objects under the class stack, one with the data type int, another with the data type string. So now here we are pushing this int stack. Here we are pushing this value 7, and then we are just printing the topmost element of that. And in the string stack, we are pushing the value, that is string value, that is the hello, and also we are printing the topmost element's content. Now we are popping out the first element, and that will be popped out. And the second time we are calling this particular pop. As we have found that we have pushed only one element in the string stack, so the first pop will work, but the second pop will produce one exception, and that exception will be handled. And in this case, this is the exception const, the reference ex, and here ex dot what. So this is the respective method which is already defined under the exception. And here you see, we can find this one, that when we are popping and we are throwing one exception whenever we are finding that elements.empty is returning true. So now let me execute my code for the better understanding. So if I do the compilation and execution of the program, then we are finding this one in this way. So the first two push operations will be done perfectly okay. So 7 and hello. So 7 has been popped, So we have pushed the value 7 at first, and then we just print the topmost element, and that's why we got this particular value 7 here. And then we push the value hello here on the string stack, and then we have print the topmost element using the function member function, that is top. So that's why hello got printed. But when we are trying to pop the first element from the string stack, so the hello will be popped out, so that will be no exception. But whenever I shall go for the second time pop method call from the string stack corresponding object, then obviously that will produce one exception, and this exception has been handled here. So in this way, we have explained this program line by line, and this program depicts that how this template can be used as a generic data type for the class also.
Default values for parameters.
At first, we are considering the function sum. So int is the return type argument for sum function, and int a is the first input argument, and another one is your int b. But this int b is having some default value, so that is equal to 20. So this b is having a default value. This parameter is having a default value of 20. So int result is the local variable within the sum function. Result is equal to a plus b return result. So now from the main function, this particular sum function will be called. So a is equal to 100, b is equal to 200, int result. So whenever we are passing this 100 and 200 through a and b, to the sum function. So sum function will do the sum and it will perform the addition of 30 as result, and that will be assigned to result and that will be returned. So the return argument will be dumped here onto the variable result. So when this result is going to get printed, so we are expecting that it will just print 300 as the output, because we know that 100 plus 200, 300 will be the return type argument and that will be assigned to the respective variable result here. Okay, now see, in this case we are passing only one argument. Other argument we are not passing. So here we are passing only 100 through A, and other argument we are not passing. So the default value, which is 20, will be now coming into the action. So now this 100 plus 20, 120 will be the sum that will be dumped onto the variable result, and the 120 will be returned and that will be coming to the variable result, and result is going to get printed. So in the first sum, the sum will be 300. In the second case, when we are calling the sum with one parameter, with one argument, that is A, with the value 100. So the second parameter, the second argument will be taking the default value 20. So the total value will become 120 in this way. So thus we are getting this proper explanation why these outputs are 300 and 120 when you are calling the function with two arguments and one argument respectively.
C++ assignment operators.
Let us explain the execution of this program now. Here we are having this int a is equal to 21, int c, which is uninitialized, c is equal to a. So let me execute my code so that we can get the idea that how the outputs are obtaining. So I'm executing my code now. So this is the output screen we are getting. So also I'm putting this notepad side by side to do any rough work. Okay, int a is equal to 21 and c is defined but uninitialized. C is equal to a and the value of c has got printed. So c has got printed as 21. C is plus equal to a, that means c is equal to c plus a. So c is having value 21, a is having value 21. So 21 plus 21, 42 will be the new content for c, and that has got printed here. Now c minus equal to a, so 42 minus 21. So c is equal to c minus a, so 42 minus 21, so 21 will be the new value for c. So 21 is coming for the new value for c. Now c star equal to a, so now c is having the value 21 and a is also having the value 21. So 21 into 21, the multiplication is taking place, and that is 441. So in this way you are getting this 441. So now c slash equal to a, that means c is equal to c by a. So that means 21 squared by 21. So that is 441 by 21 is equal to 21 will be the new value for c, and yes, the value of c has got printed as 21. Now c is equal to 200 and c percentage a, percentage is equal to a, that means c is equal to c percentage a. That means the value of 21, this particular value 200 rather, will be divided by 21 and the remainder whatever is getting obtained, and that will be assigned to c. So the value of c has become 11 in that case after doing this remainder operation. So c, there is a left shift equal to 2. So that means that we are going to shift the value of c towards the left hand side for 2 bits place. So we know that 2 bits place left shift means 2 to the power of 2, that is 4 will be multiplied in the resultant value for c. So 11 into 4, so the output will be 44 in that case. So now again we are doing the right shift for 2 places, and as we are doing the right shift for 2 bit places, so that 44 has to be divided by 2 to the power of 2, and that is 2 to the power of 2 means 4. So again we are getting back this 11. Now c and 2, so 11 means we know that if you write 11 in byte form, and that is 8, 4, 1, 2 and 1. So it is 11 is nothing but 8 plus 2 plus 1. So that's why I have placed 8. That means 1 I have placed in the position of 8. So 0 I have placed in the position of 4, and in the position of 2 and 1 I have placed 1 and 1. So now if it is getting ended with the value of 2, so that is 0 0 1 0, then I'm going to get, after doing this ending, I shall be getting this 2 as a result, so which is nothing but 2. So that's why after doing this AND operation we are getting this 2, and then we are doing this XORing with 2. So we are doing this XORing, so 2 XOR 2, always it will be 0, because similar bits XOR will produce the output 0 in that case. So if we do the XORing between these two, if we do the XOR, then obviously the output will be 0. So similarly, I'm getting this value C is equal to 0. And in the last, we are doing this ORing with 2. So with this result, if we do the ORing, then obviously the output will be 2 again. So in this way, the output has become 2. So in this way, we have explained that how the outputs are coming, and the same outputs will be obtained in case of GNU++ if you go on compiling our program in GNU++. So in this way, we have explained our code with the proper tracing, that how the values are getting generated.
C++ calling a function.
Now let us explain this program. So int a is equal to 100 and b is equal to 200. Rate is another variable defined. So in the max function, we have passed the values of a and b. So this a and b, they are supposed to get assigned to num1 and num2. So now in the parameter num1 and num2, they will get initialized with the current values of a and b. That means they are 100 and 200. So now we are checking the value of the comparison of between this num1 greater than num2. We know that 100 is greater than 200. This condition is false. So the control will be coming to the else part, and result will be equal to num2, that is 200. Otherwise, the result will be equal to num1. So the result will be assigned with the current value of num1. So here this particular condition is false, so control will be coming to the else part, so result will get initialized with the current value in the variable num2, and the value of result will be returned. The return value of the result will be assigned to the rate variable, and ultimately the value of the rate variable will be getting printed. So you are expecting that out of 100 and 200, 200 will be the maximum value, and it has got printed accordingly. So now let us go for the tracing of this program, which will help us to know that how the parameters are getting passed. So to enable the tracing mode, we shall have to go to Tools, Compiler option, and then Settings, and then Linker. Then the second option, that is Generate Debugging Information, it has to be made yes. If you load this dev C++ on your system, by default, all these options will be initialized with no initially. So for this one, you should have to make that one yes and click on OK. So we came from compiler option, then settings, and then linker, and then the second option here. So I've made that one yes. Now I'm putting one break line here. So this is the break line from where the program execution will be initiated. I'm coming to the debug mode, and here I'm going for add watch. I want to watch variable A, variable B, variable ret. Also you can do in this way, we can select this num1 and go for this one, and in this way also you can add watch. Okay, so we have taken this a, b, rate, num1 and num2. So all the variables whatever we are having in this main and this max function, they have got listed in the add watch. So now I shall be going for the debug mode. I shall compile my code once. Then I shall go to the debug mode and I shall click on debug. You see my tracing bar has come up to this line. So A and B, they have got initialized with 100 and 200, and rate is uninitialized with the value 0. So now I'm going for this into function. So this A and B will be assigned to num1 and num2. So num1 and num2, they have got the values 100 and 200. So now you see num1 is greater than num2, 100 is greater than 200 is false. So result is going to get initialized. So here let me add another one, that is a result. So here you see result is still with the value 0 because this line is supposed to get executed but not executed yet. So whenever I'm just crossing this line after this execution, the control has come to this statement, that is return result, and result has got value 200 already. So this value of result which will be returned will be assigned to the rate variable. So let me check that one. Rate is still with the value 0. So we're going for this one. So now you see rate has got the value 200, and this is the line which is getting printed. So this is the line which is getting printed. You can also see that one in the output. We can also see that one in the output. So this line has got printed. Now the contour will be coming to the the control will be coming to the next line. So that is a, so after this max value, the value has got printed and return 0. So now we are going for this continue. So the program has got its execution accordingly. So in this way, the program has got its execution, and from the tracing, it is quite obvious that how we have got the values and how these parameters a and b here, from here, they have got assigned to num1 and num2. I think through this tracing, the execution, how this execution has taken place, it is now clear to you.
Hello world program on Java. So let us go for our first program to be written and to be executed on our Java Eclipse IDE.
On the Eclipse editor, we are going to type our code on to display the hello world string. In the package explorer, we are going for the right click, new and Java project. Giving the name as my hello world. You can give any other name here. So here we are going for this Java SE 1.8. All the things have been set. Now going for next. So it will create one src folder, going for finish. So my hello world has got created. This Java project has got created. On this src, we are going for this right click, new, and then going for this package. Giving the name as com.demo.hello world. com.demo.hello world. So that is my package name. We are going for finish. Then on this package, going for right click, then new, then going for class. It will go on creating a Java class. So let it be hello world. This class name and the file name must be same. So here you can find that we have given the name hello world with H and W capital letters. Rest letters are in the lowercase. Then the hello world.java will be created, and that will be having the same name as that of the class name. The package name has got displayed here. So under this, we're going to create one function, that is a main. I'm not going to type the full main prototype. We're going for this, we'll type this main and then control spacebar. We're using the Eclipse IntelliSense here. So that is the main method, which will have the prototype, that is public static void main string array args. So the respective function has got printed. So now we are going for this sysout. I shall not go on typing our system.out.println. I shall type only sysout and then control spacebar. So we are using Eclipse IntelliSense. So here we are typing here hello world. So in this way, the respective program we have typed. So here public class hello world. The name of the class is hello world. The hello world must be same as that of the file name. So the file name is hello world.java. We're going to save that one. And the first function which will start its execution is known as the main function, which will have the prototype, that is public static void main string array args. Obviously this args can be changed because it is nothing but one string array object. And instead of writing this public static, also you can write static public. So that is also allowed. So that is also allowed, but it is our common practice to write public static. So public means this particular function is accessible from outside of the class, and static means this particular function will have a single instance irrespective of the number of objects we are going to create under the class hello world. And void indicates that this function returns nothing, it returns void. And system.out.println, we will be using it to display some string on the screen, so on the console. So here the string must be enclosed within double quotes in Java. So how to execute this program? Just we shall click on this run hello world.java in Eclipse, and then the respective output will be obtained, that is a hello world. So in this demonstration, we have given you the idea that how to create a Java project, Java package, Java class, how to type code in Eclipse in that particular Java class, whatever you have created. Here it is hello world, and how to execute the code to get the output in the console. Thanks for watching this video.
In this video, we are discussing arithmetic operators available in Java.
In this demonstration, we are going to discuss different arithmetic operators whatever available in our Java code. We have defined three variables of type integer, and here we have defined one scanner class object. This scanner class object, using it, we shall take inputs from the keyboard, and then we are going to perform addition, subtraction, multiplication, division and other arithmetic operations using Java arithmetic operators. So scanner is equal to new scanner. So this is a new scanner is a constructor we are calling so that we can instantiate this scanner object. And system.in, it is depicting that from the system's default input device, that is our keyboard, will be getting stream of characters. And then we are taking this input from the keyboard and also we are converting it to the respective integer using this method next int, and that will be assigned to a at first, and next time I'm calling scanner.nextInt method, it is assigning the input integer value to b variable. And now we are doing this addition. The addition operator is plus, subtraction operator is minus. This is a multiplication operator star. This is an arithmetic division operation, that is our slash font slash. Here we are having the remainder operation to get, there is a modulus. We are getting this one as percentage, and in this way whatever the results we are getting, and they are getting printed accordingly. So in this way, and at the end of the code we are just closing the scanner object. So we are going to use different arithmetic operators in this demonstration. So let me execute my code here. So enter the value of a and b, that means this line is getting executed. So now it is asking to input two values, and first value will be assigned to a and the second value will be assigned to b. Let us suppose I'm putting the value say 100 and say 12. In that case, what we are getting after addition, it is 112. It's perfectly okay. Subtraction 88. After multiplication means we are doing this one using this star, that is a multiplication here we are having. So that is 1200. Here we are doing this division operation, this arithmetic division using this slash font slash. A and b both are of the type of integer, so the quotient will be also of the type of integer. Result has been defined as integer type of variable, so we are not going to get any fractional part here. So we are getting 8, and then remainder, that means 100 by 12, that means 100% is 12 here to get the remainder, and as a remainder we are getting here 4. So in this demonstration we have explained that what are the different arithmetic operators in Java available and how to use them in our Java code.
Here in this video, we are discussing unary operators in Java.
In this demonstration, we are discussing unary operators. We have defined two variables var1 and var2 of type integer. var1 is equal to 50. So assigning 50 to the variable var1, and var2 is equal to minus of var1. That means here we are using this unary minus. Unary means this particular operator is requiring only one operand to operate it on. If I write minus 10, here minus is requiring only one operand, that is 10. But if I write 10 minus 5, here minus operator is requiring two operands, 10 and 5. In that case, the operator will be known as a binary operator because it is requiring two operands. But if you write only minus 10, then the minus is actually working as one unary operator. So minus unary operator to invert the sign of the value of var1, and now we are printing the value of var1 and var2 both. So if I go on executing, I can find that one. This var1 is still with this 50. The var1 is still with this 50, but var2 has got the value minus 50 here. Next one is that var1 is equal to 50 and var2 is equal to var1 plus plus. That means you can find that this plus plus operator is nothing but one unary operator. It is requiring only one operand, that is a var1, and here we are doing the post increment. That means at first it will store the value, then the value of var1 will get incremented. So store previous value, then increase var1 by 1. So we have written everything in our comment. So var2 is equal to var1 plus plus. So as a result of that, you can easily find that the var2 has got the value 50, and var1 after doing this increment has got the value 51, because the previous value of var1 will be assigned to var2, and that is 50, and then var1 will get incremented by 1. So var1 itself will have the value 51 here. So that is happening in this particular output line. Next one is that we are doing the same, but here we have written this one as plus plus var1. That means pre-incrementing, increasing var1 by 1 and then assigning it to var2. So from the 50, if I increase the value of var1 by 1, so it will become 51, and then 51 will be assigned to var2. So we are expecting that both var1 and var2 will be printed as 51 and 51. So this is a respective output line. So next one is that we assign var1 is equal to 50, and similarly we have done the post decrementing, that means store the previous value and then decrease var by var1. So in this way it is going to do that one. So I'm just let me explain it here. So var1 is having the value 50, so 50 will be assigned to var2, and then var1 will become 49 here. So as a result of that, you can easily find that here we are having this 50 for var2, and then var1 has got decremented by 1, so it has become 49. So at first 50 will be assigned to var2, and then var1 will be decremented by 1, so it has become 49. Next one is our pre-decrementing. So pre-decrementing means that here we shall be decrementing the value of var1, so it will become 49, and then that 49 will be assigned to var2. So both var1 and var2 will have the value 49 and 49 respectively. Boolean bool1 comma result. So that means here we have defined two variables, bool1 and result. Bool1 is containing the value true. That is, a not of bool1 will be assigned to result. So as a result of that, if you print bool1, it will print true, and if you print result res, then it will print not of true, that is false. So let us go for the execution. You can find that the bool1 is true and result is false. So in this way, in this demonstration, we have given you the idea that how these unary operators can be operated in our Java code.
Bitwise operators in Java.
Here in this demonstration, we are discussing bitwise operators available in Java. So we have defined two variables, val1 and val2, with the values 12 and 10, and they are of the type of byte. So the binary representation of 12 in byte, that means in 8 bits we have written, and also the binary representation of 10 in 8 bits, we have mentioned that one. So byte result, so we are defining another variable result here. So it has been represented as res. So result is equal to byte of not val1, that is a bitwise complement val1. So this is known as a not. Also the operator is known as tilde operator, and we are converting it to that byte type and assigning to this result. Now what is happening here? So this val1 is actually containing 12. That means there is a binary representation of 12. So 12 means 8 plus 4. That means at the 8 and 4 place we'll be having 1, and rest bits will be filled up with zeros. So now to get that one's complement of it, we're getting this one as 4 times 1 and then 0, 0, 1, 1. So that is the not of val1. So if I print this one, we're getting here minus 13. Now question is coming in mind, why it is minus 13? Why the value has got printed as minus 13? We know that when the first bit is 1, then the number will be treated as a negative quantity, and to get the magnitude, I should calculate its 2's complement. So 2's complement means 1's complement, that means zeros will be replaced by 1 and 1's will be replaced by 0 plus 1, and that is the 1's complement plus 1 will be the 2's complement, which will be denoting the magnitude part of the number, and the first bit will be denoting the sign, that is our negative, because the first bit is 1. So now what is this? This is our 12 plus 1, so that is a 13. So minus 13 will be the outcome, and that we are getting here as the outcome here. Next one is val1 and val2. So and here we are doing the bitwise AND operator, so it will be denoted by this ampersand. So now if we do the bitwise, just you can do for the columnar, just see. So here only we are having this 1 and 1. So that's why this place will produce 1 here, and rest all places will be producing 0. So this one means at the 8th place we are having 1. So if we print, we can find that after doing this ANDing, we are getting the 8 as the outcome. In case of OR, what is happening? If you go on ORing, bitwise if you go on ORing, you can find that it is 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, and the rest of the bits will be 0. So 1, 1, 1, 0 will be the outcome. So that means 8 plus 4, 12 plus 2, that is a 14 here. So that's why after ORing, we're getting this one as 14. Next, we're going for this XOR operation. In case of XOR, it will be denoted by this upper caret. That is a operator, that is a XOR operation, bitwise XOR operation. So what will be the outcome? You know that in case of XOR operation, similar bits will produce the output 0, and dissimilar bits will produce the output 1. So here I'll be getting 1, because 1 and 0 XOR is 1, and this 1 XOR 0. So 0 XOR 1 is 1. So rest of the bits will be producing 0 after XORing, bitwise XORing. So 1, 1, 0 will be the outcome. So I am expecting 6 as the result. Yes, we're getting 6 after doing the XORing. Next one is there is a shift 2 bits towards the left, that is a val1. So here you are having this val1. So I'm just shifting it towards the left for 2 bits place. So I'm just going for, so if I go for this 2 bit place, so it will be coming like this, that is towards the left. So these 2 bits will be off, will be lost, and 2 new bits will be coming to fill up the blank space. So we can find that it will be having the format like this, and which is nothing but, here it is nothing but 32 plus 16, and that should be 48. So we are expecting that the value will become 48 here. So now let me go for the execution. You can find that the value has become 48. Actually, what is happening, the bit which is at the 8th place with the place value 8 has been transferred to the place value 32. The bit which was at the place value 4 has been transferred to the place value 16. So actually we are doing 2 to the power of 2 multiplication. Actually we are doing 4 multiplication, that means 2 to the power of 2 multiplication. What is 2 to the power of 2? This 2 is actually denoting that for how many bits we are shifting towards the left. That means if we shift towards the left for n number of bits, then the magnitude will get increased by the factor of 2 to the power of n. So that's why 12 into 2 to the power of 2, that means 12 into 4, so 48 will be the outcome. So that's why we are getting here 48 as outcome. Next one is that we are going for this value 1, which will be shifted towards the right and 2 bits towards the right. Then what will happen? So these 2 bits will be lost and extra 2 zeros will be coming up. So these 2 bits will produce 2 and 1. So that means I'm going to get here 3. So that's why we're getting the outcome as 3. So what is happening if we go for n bit right shift, then actually the number will be divided by 2 to the power of n. So here the value of n is equal to 2 because we are doing 2 bit shift. So 2 to the power of 2 is 4. So 12 by 4. So 3 will be the result here. So in this way we have explained the bitwise operators which are available in Java with proper demonstration and example.
Relational operators in Java.
Here in this demonstration we will be discussing on relational operators available in Java. We have defined one variable of the type boolean. The name of the variable is result, and the first relational operator we are using, that is equal to. So 10 equal to 10, it is a condition, so it will return either true or false depending upon the condition is true or the condition is false. So true when a left operand is exactly equal to the right operand. So that will be assigned to the result. The value of the result will be printed. So you can see that the result is true here. Next time we are gone for 5 less than 5. So here this less than is nothing but one relational operator in Java. So that will be assigned to result. 5 is less than 5 is false. So true when the left operand is less than the right operand, but that is not happening here. Here both the operands are same. So that's why the result will get printed as false. So you can find that the result has got printed as false. Next one is result is equal to 5 less than equal to 5. Here less than equal to is one of the relational operators in Java. True when left operand is less or equal to the right operand. So we are printing the result and it is getting printed as true here. Next time you are using the greater than, that is a 10 greater than 5. So this greater than is one relational operator. True when the left operand is greater than the right operand. So now here the result is getting printed and you are finding that the result is getting printed as true. So we are getting this outcome here. Next one is greater than equal to. So 10 greater than equal to 5. So this condition is true. So result will be printed as true here. So the another relational operator, that is a not equal to. So 2 not equal to 2. True left operand and the right operand are not the same, but they are same here. So that's why the result will be assigned with the false and the result will get printed. So I'm getting the outcome as result is false. So in this way we have discussed different relational operators available in Java.
In this video we are discussing conditional operators in Java.
We are discussing how to use the conditional operators in Java. So here we have defined 2 boolean variables, that is a bool1 and bool2, and another variable that is our result, res. Bool1 has got initialized with true and bool2 has got initialized with false. So result is equal to bool1 or bool2. You can find that here we have used double filter sign. So true when at least one of the value, if it is true, then the outcome will be true, and that is the basic logic of OR. And in this case, this result is equal to bool1 and bool2. So that is our double ampersand, which is another conditional operator. So true when both values are true here. So here we are expecting that result will be printed as true because one of the values is true here, bool1 is true. But here we are expecting that the result will be printed as false because here this bool1 is true but the bool2 is false. So now let me go for the execution. You can find that it is true and it is false, and it is according to our logic. So now let me make it true here. Then what will happen? In the both cases, for this double filter, that is the AND, and this is a double ampersand, that is our double filter is OR and double ampersand is our AND. In the both cases, in the both conditional operators will produce the outcome as true. So let me go for the execution. You can find that they are producing the outcome as true here. So in this way, in this demonstration with the proper example, we have given you the idea that how to use the conditional operators in our Java coding.
In this video, we are discussing input-output techniques in Java.
In this demonstration, we are discussing input and output in Java. So that is one message, that is, this is an output line. This message, this particular string is going to get printed using system.out.println. Now what is system? System is nothing but one class which is defined under the package java.lang.system. That means the package name is java.lang and the class name is system. So let us go for exploration of this. So this is our input output Java program, and here you can find that we'll be going for this java.lang. You can easily find java.lang is there. So you shall go for rt.jar and then you shall go for java.lang. So different packages are given here. So let us go for java.lang. So they are arranged in the alphabetical order. So I shall go for this java and then lang. So that is my java.lang. Under this java.lang, we'll be going for the class that is our system. So if you go for the class system, they are also arranged in the alphabetical order. So that is our system class. So this is our system class has got opened. So now you see here we are having system.out. Now what is out? And this out is nothing but one printstream class object. And this printstream class object is there. And this particular object must be of the static scope. And it is written here also. There is a public static final printstream out. So this is a declaration, that is out is nothing but one instance variable under the class system. And this instance variable is nothing but one object of the class printstream. As this particular object is having the static declaration, so as a result of that, we can access this object directly from the class name dot operator. So let us go for this out. So now we are going for the system. You can find that here we are having this out here. We are having this out here declared. There is a public static vinyl java.io printstream class object out is there. As this out is having the respective static declaration, so this out can be accessed directly from system.class, system class.out here. So now this is our java.io.printstream. So let us go for java.io.printstream to check that this particular java.io.printstream class, where the java.io is the package name, printstream is the class, must be having a method that is our println. So that's why we can access it. So we are going for this java.io. So that is our java.io. We are going for that. So this is our java.io, and from here we'll be going for the printstream. So there is a class called printstream. This is a respective class, and this particular class is having a method that is a println, and this method is not static. So that's why I cannot be calling this method println directly from printstream.println, because the method is not static here. So that's why I should declare one object under the printstream class, then object name.println can take place. So that's why this system is having our out is the object of this printstream class. So out.println is allowed here. So that's why we're getting the respective help here also. We're having this java.lang.system, and this is the out. This out we're having, and this out is nothing but one printstream class. This printstream class object, that is, we're having this one as java.lang.system.out, and it is declared under the static scope. So that's why we can directly access this out from this system.out, and println is nothing but one method. This method is having the prototype, that is a void. It returns void. It is defined under the package java.io, and it is having the respective class, that is a printstream, and .println is a respective method, and it takes a string as input argument, string object, and this is a string object we have passed. So in this way the code is actually getting executed. So I have given you the explanation of the system.out.println, which is a very common question in the interview or in the exam viva. So if I go for the execution, you can find that this is an output line. This string has got printed here. Okay, so this string has got printed. Next one, we are having this particular x is equal to 10. X is of the type integer. So value of x, we are doing this one as concatenation. So string concatenation integer, so ultimately it will be converted implicitly to the string, and that's why the output is coming as the value of x colon 10 here. Next one is that we are not using print ln, we are using print and print. So what is happening, the first string and the second string, these things have got printed in the same line. But if you put here ln here, if you put here ln, then obviously these two lines will get printed in two separate rows. So there is a first string, there is a second string. So if you make this ln omitted, you can find that the second string, this string is getting printed in the same line in which the first string got printed. Next one is that system.out.printf. This is the value of x, pi is equal to this. In this way we can go on printing. So x will have this particular formatting, that is a decimal type, and this is nothing but 22f, means 22 will be treated as a float number by 7, so it will be printed as %f. So you can find that it is getting printed as 10 and 3.142857. So in this way we have explained that how this outcome is coming. Now scanner class object. So this is a scanner class object. So this is a scanner class we are having. So it is under the java.util.scanner. So java.util is the package name, scanner is the class name. Under this class we have defined one object. This object has got instantiated, is getting instantiated using this constructor. So new and then the constructor name, which is must be same as the class name. Here the class name is scanner, so the constructor name is also, the method is also known as the, will be called by the scanner. And there is a system.in. There is a scanner class object to read from the input device, and here the stream of characters will be coming from the system's in default input device, that is our keyboard here. So system.out.println enter data using keyboard. So when the data will be entered, so that can be accessed using scanner.nextInt. You see here the input will be converted to the integer, and that will be assigned to int data, and later the data is getting printed here. And scanner.close, so close the scanner object when the inputs are obtained. So let us go for the execution. You can find that it is asking for some input. I'm giving the input as 100. Now you can find that the data that has been read is 100 here. So in this way, in this particular demonstration, we have discussed that what are the different inputs and output, how we can do the inputs and outputs in our Java coding, and we have given you the detailed description what is system.out.println.
Strings in Java.
In this demonstration, we are going to discuss how to use string in our Java code. At first, we have defined one character array. This character array is containing these 6 characters, and this is known as a character array. And name of the character array is character string. We have defined one scanner class object as usual. We did that one before also. And we have defined one string class object str is equal to new string. You see in the constructor, string is nothing but a constructor here, this string method, and which is taking this character array as input argument. That means from this character array it will create a string, and that will be assigned to str. So using the constructor, passing this character array as input argument to the constructor name here the string function, and this constructor, from this particular constructor, from this character string character array, we are generating a string, and that will be assigned to the variable string object str. So say system.out.println, we are printing the value of str, and now we are going for this. So system.out.println enter a string. So using the scanner class object scanner, using the method that is our next, we are taking one input, one string as input, and that will be returned, and that will be assigned to the string object str, and then the str is getting printed. So here we are showing you that how to take the user given input, user given string as input, and how to assign that one to a string class object. Here this str is getting assigned with this particular string. So there is a Java string. So direct assignment we are doing. So direct assign string to the string type object str. Next we are printing the value of this str object. Then we are going for the string concatenation. Concatenation means adding 2 strings. So here we are adding 3 strings. One is a string, next one is this blank, and next one another string, that is concatenate. Here plus operator is being used as the string concatenation operator. So ultimately this concatenated string is getting printed, and we are closing this scanner class object. So let us go for the execution. You can find that the value of str is string. That means from this character array, which is having these 6 characters, we have generated one string, and that has been assigned to this str. And here this string constructor is being used, and this string is a class which is defined under this java.lang package. and it is taking one character array as input and generating one string as output, and that will be assigned to this str, and that has got printed. Now it is asking for the string for input, so I'm going for this hello, and then pressing enter. So the value of str is hello. So now it has taken the input from the keyboard. Next is a function which is accepting a string input, and it is returning the string as output, and that will be assigned to this str. Str has got printed, so hello has got printed. Now here we are going for the direct assignment of a Java string onto the string object str, and the str has got printed. Now here we have done the concatenation of three strings. So here this plus is actually working as a string concatenation operator. So string blank space concatenate, these three strings has got added and has been assigned to the string class object, that is str, and str has got printed. So in this demonstration we have given you the idea that how to define one string object, how to initialize one string object directly or taking some inputs from the keyboard or using constructor, and what is string concatenation.
String functions in Java.
In this demonstration we shall discuss how to use different inbuilt library string functions in our Java code and what are their purposes. Here we have defined two string objects, that is str1 initialized with this hello and str2 also initialized with this hello. Here all the letters are in capital. Here's one, the first letter is in capital and rest of the letters are in lowercase. So the first function we are using, that is the str1.length. So str1.length is a function which is defined under the string class. There is a public int length, and it denotes that it returns one integer, and it is under the public scope. So from the objects, from the string class objects, we can easily access this length function using the dot membership operator. So here see, if you go for the execution, we are getting this length as 5 because hello is having 5 number of characters in it, so its length will be 5 here. Next, str1 dot equals str2. Here both are hello string, but they are not having the same case for all the letters. So that's why str1 dot equals. Now what is equals? So equal is nothing but one method which returns a boolean under the public scope, and the name of the method is equals, which takes object as input argument. You can easily find this one here in the declaration. So now str1 dot equals str2. Now what is the outcome here? We can easily find that hello and hello are not same. That means the control is coming to this else part, because these two strings are not equal because they are having different uppercase and lowercase characters here. So but if you go for another method, that is a equals ignore case. So equal ignore case will be working as the same as equals, but here only the case sensitivity will be ignored in case of equals ignore case function. So it returns one boolean and it takes the string, that is another string, as input argument. So now if you go for str1 dot equals ignore case str2, so it is giving me the output that hello and hello are same, ignoring case. So this is the outcome we are going to get. So this particular statement is getting executed. That means it is going for the then part and else part is remaining unexecuted. Next one, system.out.println, the character at the position number 2 is str1.char@2. So what is a caret? Caret is nothing but one function, that is a public char caret int index. So it returns one character which will be placed at the index position number. Now here we are operating on this str1. We are calling this caret from this str1 string object. So first character will be at the place at the index number 0. So it will be at the index number 0. It will be at the index number 1. So L will be at the index number 2 here. So if I go for the output, we can find that the character at the position 2 is capital L. So that is coming from this L. This L has been retrieved here. Next one, we're going for system.out.println comparing str1 and str2 distance, that is str1.compare to str2. So now here you can find that this H and this H are having the same ASCII code, but this E, capital E and the small e will have the ASCII code difference of 32. We know that capital A is having the ASCII code 65 and the small a is having the ASCII code 97. So always the same character in the lowercase and in the uppercase will have the ASCII code difference of 32. So uppercase characters will have the ASCII code 32 lesser than the same lowercase character. So here we are doing this one as capital H ASCII code minus capital H ASCII code. The value is 0. So for the non-zero difference it will return, for the 0 difference it will go on continuing. So the next one, this E ASCII code and this small e ASCII code, the difference value will be minus 32. So as a result of that, we are getting the outcome as minus 32 here, because we know that capital letters ASCII code will be 32 lesser compared to the same letter in the lowercase and its respective ASCII code if we consider. So now we are going to have this str1 and str2 initialized with the strings. You know, the str1 and str2, they have got initialized with the strings. Now for the rest of the operations, we'll be considering them. So here we are having str1 dot starts with AAB. So str1 really it is starting with the string AAB. So now what is the starts with? So starts with is nothing but one function which returns boolean under the public scope you can easily find, and it will take a string as input argument. So this particular string is nothing but a prefix. So here this AAB is really the substring with the help of which str1 has started. But str1 dot ends with ACA. Really it is not ending with this ACA, so here it will be returning the boolean value, and that will be false here. You can find that public boolean ends with string suffix, and here it is returning, we are expecting it to return true here. So let me go for the outcome. You can easily find. So here we are getting this one as true, and here we are getting this one as false, as we have explained earlier. Next one is this one. That means first index of BB in str1 is str1 dot index of BB. You can find that BB is occurring in multiple places in str1, but it will consider the first occurrence of BB. So it is starting from the index number 2 here, because it is 0, index 1 and index 2. So it will be starting from the index number 2. So this is my index of, which is nothing but a function public int index of string str. So there is an integer it will return, that is it will return the index. So let me show you that what is the outcome we are getting. So here we are getting this one as 2, as we expected. Next one is last index of. In case of last index of, we will be searching for BB, and the last index will be returned. So now just consider this one as index 0, 1, 2, 3, 4, 5, 6. So from the 6th index, BB will be found. So we are getting this outcome as from the 6th place. So this part we have covered till now. Next one, we are going for this. Replacing ABB to XY of str1 is. So str1 dot replace ABB XY. It is one point to be noted that the string which is going to be replaced is having the length 3, and which will be replacing will be having the length 2. That means these two strings may or may not have the same length here. So you can find that ABB will be obtained here. So that will be replaced by this XY, and this ABB will be obtained here. So that will be replaced by this XY. So now let us go for the outcome. We can find this one as AXY, CXY, and then we are getting this one as AA. So AXY, CXY, AA. So that is the string after getting replaced. Next one is that str2 substring 5, 11. You can find this one as we're having this particular substring, and it is public string substring int begin index, int end index, returns a string that is a substring of the main string. The substring begins at the specified location, that is a specific index, that is the begin index, and extends to the character at the index in the end index -1. So that is very important. That means this 5 will be inclusive, but this 11 will be exclusive. That means it will pick up characters starting from the index 5 to the index 11 -1, that is 10. So let me work on that. So for this str2, so index number 0, 1, 2, 3, 4. So it is starting from the index number 5. So 5, 6, 7, 8, 9, 10. So it will return string whatever we have calculated. So let us go for the checking. So you can find that it is returning the string. So that is the outcome we expected here. Now let us go for the next part of our code. So here we are having, we have covered the substring now. Now we are going for this split. So this is a test string. str1 is containing that one. So now string array, split array. So split array is the name of the array, which is a string array. And here str1 dot split. This split is actually taking one regular expression as input argument. So it is taking the delimiter with the help of which the string will get splitted. Here the delimiter has been selected as this hyphen here, because the string is containing hyphen for multiple number of times, and the split function returns one string array. So this here the array name is split arr. So now using the for each loop, we are going for string sp colon split arr. We are going to print this value of sp. So for each and every iteration, it will pick up one substring, and that string will go on printing. So you can find this one as this is a test string. So this is the respective substring they have picked up. The string has got splitted into and the outcome has been kept in the string array. And now using the for each loop, we are picking up each and every string from the string array and printing that one accordingly. Now this is my string, which is str2, where we are having lots of blank spaces are there, lots of blank spaces prepended and appended here. So if you print this str2, the outcome will be like this. You can find that this str2 has got printed. So before doing the trim operation, you can find that so many blank spaces beforehand and so many blank spaces afterhand. But if you go for str2.trim, you can find that these two brackets are coming very packed, very tight here. That means all the redundant blank spaces, leading and trailing, they have got truncated out, they have got discarded here. So let me do one experiment. If I put multiple blank spaces within the string itself, not only the leading and trailing, but multiple blank spaces within the string itself, then what will be the outcome? You see, the trim is doing nothing with the blank spaces, multiple consecutive blank spaces within the string. So that is not getting discarded. They are remaining the same, but all the leading and trailing blank characters will be discarded, will be truncated out using the method that is a trim. So if you put my mouse pointer on this trim, we are finding this one as public string trim. So trim is nothing but a function defined under the string class, and it returns the trimmed string as outcome, as the output. So in this way, we have used multiple different inbuilt functions in our string class in our sample program.
String buffer and string builder in Java.
In this demonstration, we are going to discuss string buffer and string builder class objects. At first, we are dealing with the string buffer. So here you can find that one string buffer object, class object has been defined, that is sBuffer, which has been instantiated with this constructor here. And the default capacity of this sBuffer will be 16 here. So let us go for the execution. You can find that when you are printing this sBuffer.capacity, we are getting here 16. This sBuffer is now instantiated with the string buffer constructor, and here we are setting the capacity directly as 50 here. As a result of that, when you are setting that one, so it is having the capacity 50. So now again we are defining this sBuffer with this string buffer constructor, and here we are passing one string as input argument. Then what will happen? The 16 plus the length of the string will be the total buffer capacity. What is the length of the string? If you go on counting, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So 15 characters are there plus 16. So you are expecting the capacity would become 31 here. And here we are printing the sBuffer directly. So sBuffer has got printed, that is my string buffer. Next, we are dealing with the string builder objects. So string builder sBuilder is equal to new string builder my string builder. So this is a string which will initialize this sBuilder. So if you print this sBuilder now, this object, if you print, then it is printing my string builder. Next one is that with this sBuffer we are appending a new string. With this sBuffer we are appending a new string here. So and also with this sBuilder object we are appending another new string. So here we are mentioning one method. That method is known as the append, which is public return string buffer object, and then its name of the method is append, and it takes a string class object as input argument. Everything has been mentioned here. So now after doing this append operation, then what is the net outcome? You can find that the pre-existing content is surviving. The pre-existing content is up to this part, and the new content has got appended at the end, and similar thing has taken place in case of string builder class objects also. Next, we are initializing this sBuffer and sBuilder with a new string. So there is one string, that is another string. So sBuffer dot insert 5 pqrst. So what is the outcome here? You can find that it is producing the outcome, that is AABCA, then pqrst, then BBC. Why it is so? Because 0 1 2 3 4. So after this fourth, the fifth position, at the fifth position this pqrst will get inserted, and then BBC will be there at the end. You can find that we are having the same thing. So 0 1 2 3 4, then at the fifth place pqrst has got inserted, and the remaining part of this sBuffer is there. Next, in case of string builder, if you do the insertion here, that is at the third place we are inserting XYZ. So what is happening in this case? So 0 1 2, then at the third place XYZ has got inserted, and the remaining part of this sBuffer is still there. Next, we are going for the reverse. So sBuffer.reverse and sBuilder.reverse. So this particular reverse method will actually reverse the content of this string builder and string buffer objects. So you can find that the reverse is obtaining has been printed, and reverse of this current content has got printed here. So in this demonstration, we have discussed how to deal with the string buffer and string builder class objects, and what are the different necessary methods or whatever we can use in our coding for storing our string in a certain better way.
In this video, we are going to discuss static keyword in Java.
In this demonstration, we shall discuss the keyword static in our Java programming. Now, what is the static keyword? So here we are having one class. The name of the class is static demo, and it is having int static var. So there is one variable, and this variable is of type static, and this is another variable which is a non-static, that is int var. So static variable we have defined as static var of type int, and non-static variable we have defined as var of the type int. So this is the constructor which will initialize the non-static variable var, which will be equal to 0. Next one. Here we have defined another static method. Here we have defined one static variable. Here we have defined the static method. So public static void set static var int x, and this x will be assigned to this static var, that is a static variable. So always remember, in case of static method, they can access only the static variables. Non-static variables cannot be accessed from here. So if I want to write this one as a var say is equal to 100, if I write here, so it is having one error message is coming, and that error message is telling that cannot make a static reference to the non-static field var. So that is the error message we are getting, because non-static method cannot access static method cannot access non-static variables. So that is very important. Next method is known as the increase. This method will increase the value of the static var by 1, and also value of the non-static var, that is var, as 1. So in this way, two variables have got increased here. So we have got one lesson that static method can access only the static variables, but non-static method can access both the static and non-static variables. Next one is a display, which will print the current value of static var and the current value of var as well. So now here we are defining the class, that is the keyword static, which name is same as that of the file name here. So under this particular keyword static, we are defining the main function. We are defining two demostatic objects, that is the st1 and st2. They are defined under the class demostatic and instantiated with the constructor and the new keyword. So here we are having this st1 dot increase, st1 dot increase. So 2 times the static variable will be increased here. Always remember, so irrespective of the number of objects we are going to define under the class here is static demo, only one instance of the static variable will be defined here. So only one instance of the static variable. So this static var will be defined once only, irrespective of the number of objects we are going to define under this class, that is the static demo. As a result of that, st1, when it is increasing the static var by 1, then same increase function will be called from the st2. It will be also increasing the same static var by 1. But as the var is a non-static variable, so it will have a 2 separate instance with respect to st1 and sp2 separately. So as a result of that, when we are calling this st1 dot increase, the var which is getting increased 2 times, because we have called this function increase twice. So this instance will be totally different from this st2 dot var when we are calling this increase for 3 times. So another new instance of var will remain created against this st2 object, and that will get increased for 3 times. So I think now the conception will be cleared if you go for the execution. So the value of the static variable is 2 and value of the non-static variable is 2 here, because here we have called this st1 dot increase 2 times. So the static and the non-static, both the variables have got increased by 1 and 1, and initially their values were 0 here, because we have initialized this one as 0, and automatically the static var will be instantiated with the value 0, will be initialized with the value 0 initially. So st1.display is displaying that both the variables are having the value 2 and 2. Now from this st2, this increase function has got called thrice. So the static variable will get increased starting from 2. So 2 to 3, 3 to 4 and 4 to 5. But this var will be having a separate instance for the new object st2. So it will be increased from 0 to 1, 1 to 2, and 2 to 3. As a result of that, when we are going for s22.display, we are finding that the static variable is having the value 5 and the non-static variable var is having the value 3 here. Here we are having the set static var. So here we are putting this 50 and 50 will be assigned to this static var variable. So if I print this particular variable, we can have this one as 50. You can find that we are having this one as 50. So this particular method, static method, has been accessed from the class name directly. From the class name directly it can be accessed, and this static variable can be accessed from the class name. Now if I use this one as st1, and also here as st1, you can find that they are executable and we are getting this same output here. Static variable without object is 50. So now if I call it from the st2 also, they are accessible because they are static. So irrespective of the number of objects we are defining under the class, the static demo, these two static members, variables and methods, will have a single instance in the computer's memory, and they can be accessed either using object name dot or using class name dot directly. So in this way we have shown you that how to use the static keyword in our Java code.
In this video, we are discussing class and objects in Java.
In this demonstration, we shall discuss class and object in Java. So here the name of the class is student, and this particular class is having 3 member variables of the student class, and their string name, int id, and string measure. So as here we haven't mentioned them that they are under a private scope or public scope, that means they are in the default scope. So here we are having one method. The name of the method is setName. From the name of the method, it is quite obvious that it will take one string as input and which will set the name instance variable here. And similarly for set measure, it takes a string as input argument and it initializes the measure instance variable. And the display method is actually printing the name, id, and the measure, and in this way all the 3 instance variable contents will get printed using this display method. So here the name of the program is class object.java. You can find that this particular class is having class object.java. You can easily find that in the same Java source code we have declared 2 classes. One is the class student and another one is the class object. So what will happen if we define multiple classes in the same Java program, in the same Java source code, then one of the classes will be of the type will be under the scope public, and main function will be defined in one of the classes only. So this public static void main string array args, and here we have defined 2 objects under the student class, and those 2 objects have got instantiated, memory spaces have got allocated, and they have got instantiated by using new student class constructor. Now we are using the set name, we are using the set measure to initialize the name and the measure instance variables, and directly we are writing s1.id is equal to 1021 to instantiate or to initialize this id instance variable. So similarly we have done the same for the s2. S2 is another object under the class student and which has got instantiated using the constructor of the student class. And now we are going for the s1.display and s2.display methods. So let us go for the output. So the student name Joy has been printed, the student ID 1021, and major subject here computer science, and in this case the name and the ID and the subject has got printed, and they have got printed after calling the method s1.display method and s2.display method. So in this way we have discussed that how the Java, in case of Java, how we can define one class and then how to define objects under the class and access class members.
In this video, we are discussing Boolean type data in Java.
In the demonstration, we are going to discuss Boolean type of variable, that is the mybool. So Boolean mybool. So mybool is a variable of the type Boolean. Mybool has got initialized with a value that is true. Here you can find that in case of true, all the letters are written in the lowercase. And then we are trying to print the value of mybool there. And mybool is equal to false. We are setting the value of mybool with false. That is, we know that Boolean data type can have 2 values, either true or false, and then it is printing there's mybool there. So let me go for the execution. You can find for the first time mybool has got printed as true. For the second time mybool has got printed as false. So now let me go for some other experiments. Here I'm writing here 100. So now if I go on printing, I'm finding that it is producing error because proceed. You can find that it is producing error because this my bool cannot hold any other data types value. It can hold only true and false as it is showing the respective error message. So the error message is showing that exception in thread main java.lang.error, unresolved compilation problem, type mismatch, cannot convert to int or boolean. From int to boolean, because 100 was int, it cannot be converted to boolean, and that's why it is producing one error at the line number 13 here for this respective Java code. So that's why you can find that this particular boolean variable can hold only the value true and false, cannot hold the value of any other data types data. So that's why in this demonstration we have given you the idea how to deal with the boolean type of variable. Thanks for watching this video.
In this video, we are discussing character type of data in our Java coding.
In this demonstration, we are going to deal with the character type of variables. We have defined one character type variable, that is a mycar. And this mycar has got initialized with this capital A enclosed within single quotes. That means the direct assigned character capital A, which will be enclosed within single quote. And in our Java programming, whenever you are trying to deal with the characters are to be enclosed within single quotes here. So system.out.println, the value of mycar I have printed here, and so the effective outcome is capital A. Next one, this mycar has got initialized with this 70. What is the 70? 70 is the ASCII value of character F. 70 is the ASCII value of character F, because we know that capital A is having the ASCII code 65, so F will have the ASCII code that is our 70. So after assigning this 70 to this mycar, if I go on printing this mycar, remember mycar was defined as of the type car. So that's why whenever we are going to print this mycar, it is printing capital F, not 70, because it is a character type of variable. Here in this case, the mycar has been initialized with /u0041. There is a Unicode hexadecimal value for integer, and this value will be ranging from 0000H to FFFFH. Here H stands for hexadecimal. So as a result of that, when we are assigning /u, that means a Unicode hexadecimal format 0041. So 41, if we want to convert this 41 to the decimal equivalent, it is 4 into 16 to the power of 1, that is 64, plus 1 into 16 to the power of 0, that is 1. So 64 plus 1, that is 65. That is the ASCII code of capital A. So if I go on printing this mycar, you can find that mycar is printing capital A here. So in this way, we have shown you that how to deal with the character type of variables in our Java code. Thanks for watching this video.
Inheritance in Java.
In this demonstration, we shall be discussing about Java inheritance. At first, we are defining one base class. The name of the base class is employee, which is having protected double salary, and that is our 30,000 D. Here D stands for the double. So this particular 30,000 is of the type double here. So here we are having one constructor. The name of the constructor will be same as that of the class name, that is our employee, and one line of code is there to print one message. This developer is nothing but a subclass, and this subclass means the inherited class, and where the base class or the superclass here is the employee. Here also we are defining another class, that is a subclass or inherited class, and this particular subclass is also having the same base class, that is employee. In the both cases, we are defining bonus. Here it is 20,000, here it is 10,000, and here it is 20,000. And this is the developer constructor, and this is the tester constructor, and only one string will get printed in the constructor from the constructor body. So this is the total structure of the classes, and here we are having one display salary. You can find that this particular salary was under the protected section. That means they are inheritable. So that's why this salary can be accessed from the derived class, that is our developer, and this tester also, this salary is accessible. So here when we are printing the display salary, we are just adding the salary and the bonus. The salary and the bonus is nothing but the instance variable of this developer, and salary is the inherited variable, inherited instance variable, and that is the salary, and they are getting added and the sum will get printed. Similarly here also, the bonus is initialized with the value 20,000, that is a instance variable under this tester class, and this salary is the inherited instance variable. So that's why they are getting added. They can be added, and the sum of them will be the total salary going to get printed. So here we are having the class that is the inheritance. That is a public class inheritance. Inheritance.java is the name of the file, name of the source code, and here we are defining the main function. And under this main function, we are defining the developer class object and instantiating with the developer constructor, and tester class object instantiating with the tester constructor. In the both cases, we are displaying the display salary method from the respective objects here. So if you go on printing, you can find here it is printing 40,000, it is printing 50,000, because the salary, you can find here the salary here in both the cases, after getting inherited, the salary inherited instance variable will be having 30,000, and this 30,000 plus 40,000 for 10,000, that is a 40,000 will be the salary for the developer, and 30,000 plus 20,000 will be the salary, that is a 50,000 will be the salary for the tester here. So as a result of that, we are getting the salaries got printed as 40,000 and 50,000 for the developer and for the tester respectively. I think now you are getting this idea how the inheritance can get implemented in Java code.